Good morning, students. Actually, today I will discuss about the application of change in mechanical input power. Now, where mechanical input power is given to the alternator. Now, what happens if we change the mechanical input power suddenly, or maybe mechanical power input is constant, and if you change the load on the machine suddenly, what happens? Like we can take the example of 5th April. That PM has asked all of us to switch off the lights at 9 p.m. Now what happens just before 9 p.m. All the lights or all the appliances are connected to the system. Once everyone starts switching off their lights, what happens? The electrical power demand becomes less, reduced to a very less value. That times, actually if mechanical input power is constant, the machine, there will be imbalances between mechanical and electrical power, and due to that machine performance will be different. And similarly, if we increase the mechanical input power suddenly, that times what happens? That times also similar things happens. Due to the imbalances between mechanical and electrical power, the machine will accelerate and deaccelerate. That things takes place. So before going to this topic, you actually should have the knowledge of the performance or behavior of the synchronous machine in when there is no change in load, when there is change in load. Now, power system performance actually depends on the machine behavior, how the machine behaves during any abnormal situations. So that can be actually explained by this 3 points. Now, when there is no load change, the machine is running at synchronous speed, and means as there is no load change means the angle delta, load angle, or we can take it as torque angle, will be, there will be no change. Similarly, when here I have indicated this PS and P, or I think already you know, this PS is the mechanical input power and P is the electrical output power. Now what happens if mechanical input power is more than the electrical output power? So as I said, this accelerating power is PS minus P. So as PS is more than the PE, means accelerating power will be positive. So due to that accelerating power, the load angle delta will increase, and due to increase in delta according to power angle relationship, which is EV by X sine delta, this P will increase. Similarly, when PS less than P means mechanical input power is less than electrical output power, that time accelerating power, which is the difference between mechanical and electrical power, will be negative, means negative accelerating power, means deceleration. So due to the deceleration, the load angle will reduce. As load angle reduces, so from this equation EV by X sine delta, we can say the electrical power output will reduce. So coming to the next, see, this actually, the sudden load change or sudden mechanical input power can be explained by using equal area criteria. Now what happens? Let's take this is the power angle curve. Means power angle curve actually represents the electrical power output, which is P equals to PM sine delta. Delta will vary. Now initially, let's say mechanical input power is P0. So corresponding to this power, delta or load angle is delta 0. So machine is operating at this point, and at this point it is operating with synchronous speed, suppose. Now what happens if we suddenly increase the mechanical input power to PS, means this line. So at that point actually P0 mechanical input power initially was equals to electrical output power. So machine was running at synchronous speed because there was no accelerating power. So once we increase it, means if you see this, our electrical output power is this one, but mechanical input is this much. So what will happen? Here mechanical input greater than electrical output, means the machine will accelerate. So once the machine accelerates, therefore the angle, load angle will increase. So it will increase, suppose till point B, and at B the mechanical power is this much and suppose angle is delta S. So if moving from this point to this point, the machine is accelerating. So due to that acceleration, our load angle, the machine load angle will increase. So as load in angle increases, means delta increases, that's why if this delta increases, electrical power output will increase. So suppose at this point these two powers again becomes equal, like PS is equals to PE. So means the acceleration force will be 0 here, but due to this acceleration whatever stored energy is there, and due to the inertia of the rotor, machine angle will further increase. So due to that angle increases, due to angle increasing, the electrical power output will further increase. Now at this point what happens? What happens to the speed of the machine? See, here speed was synchronous speed, and after that point acceleration starts, means speed will increase. So while going from this point to this point, at point B the speed will be above the synchronous speed, because at this point it was running at synchronous speed. Now once we cross this point, acceleration force will be 0, but due to the inertia of the rotor the angle will further increase. So suppose it will increase till delta m. Now due to this increase of delta, the power will increase, electrical power. So electrical power is increased. Suppose at the point C again the whatever stored kinetic energy was there during acceleration, that has been released totally. So and these two areas, this is accelerating area and this is deaccelerating, because at this point if you see the electrical power output is more than the mechanical power input, means PS minus P is negative, means accelerating power is negative. So as accelerating power negative means deacceleration effect will be there. So when these two areas are equal, so at this point all the accelerating energy has been released or cancelled by the deaccelerating energy. Therefore the machine will again run at synchronous speed at this point. Now let's see, once we move from this point C to B, once we move from point C to B, how the machine will behave. Now at the point C, machine will actually again run at synchronous speed, because this point it was above synchronous speed and here deacceleration starts, means speed is reducing. So once it reduces, it will again reach at synchronous speed. So at point A and point C machine is running at synchronous speed, and at point B machine speed will be more than the synchronous speed or above the synchronous speed while we are going from this side to that side. Now let's see after point this C from B to from C to B, the electrical power is more than the mechanical power, means deceleration will be there, and due to that deceleration speed reduces. So as speed reduces means angle will reduce. So or due to the deceleration angle will reduce. So as angle will reduce, suppose at point B again it has reaches the delta S. So at this point what happens? The acceleration is there. So while coming from this side to that side at point B the speed will be below the synchronous speed because at this point it was at synchronous speed. So after crossing this point we can see the mechanical input power is more than the electrical output power. Now acceleration will start. So again if we cross this point B, the machine speed will now again start increasing, but that will be below the synchronous speed. Can't jump immediately to the synchronous speed. Now suppose at the point A again all this accelerating and deaccelerating energy has cancelled each other. At this point there is no deacceleration, so machine will again run at synchronous speed because of the accelerating power as our mechanical input power is more, and this cycle repeats. And if proper damping is there, the machine angle oscillates or the machine oscillates between point A to C, and finally if due to the damping it will reach the new operating point B or new operating angle delta S, because the mechanical power is constant and electrical power is the adjustable one, and the machine will change its output in such a way it will reach this point where mechanical power is opposed to electrical power, and there will be no acceleration deceleration, so it will run at synchronous speed at this point. So this is the application of mechanical change in mechanical input power to the system behavior, or that actually behavior of the synchronous machine. So till this I'll give you the notes and all, and in this slide also everything is available. Like you can see this every point, this load angle, machine speed, power, acceleration, deacceleration, all these things are mentioned. So you can go through it. If you have any doubt, you can ask me through WhatsApp or maybe through Google Classroom. I will share this with you in the Google Classroom. And this is the things, the theory is written. The same thing is explained here. You can go through it.